So we've got these two formulas here: R total equals R1 plus R2, and then the 1 over R total is equal to 1 over R1 plus 1 over R2, and so this one's for series, this one's for parallel. This is the derivation for it. You need to first remember that the total voltage is equal to, in series, the total voltage is equal to V1 plus V2. Voltage is the difference in energy per charge, or for now we can just think about it as just the energy per charge. So that means as they go around this circuit, they lose some of their energy here and the rest of it there, and then go back to the beginning. So the total voltage is going to be equal to the sum of the two voltages. By using this equation here, we can sub in, instead of writing V total, we write I multiplied by R total. Instead of writing V1, we might multiply I multiplied by R1, and so on and so forth. And because the current is the same everywhere, they all cancel out, and we have that formula there. Likewise, in the parallel circuit, this time the voltage is the same everywhere, because in terms of the energy, the electrons, they use up all their energy, because all the electrons go through only one resistor, but they may go through different resistors. Some will go through this one, some will go through this one, but they all use up all their energy, and so the voltage is the same everywhere. So V1 is equal to V2, which is also equal to the total voltage in the first place. But what is different is the current this time, which is the same in the series circuit. In this parallel circuit, it breaks up at a junction. A junction, by the way, is the foolproof way of identifying whether or not it's a parallel circuit. Don't think about parallel lines. Think about junctions. If it's got junctions, it's a parallel circuit. That's that. So at the junction, the current breaks up, and some goes through there, some goes through there, and then it joins back together again. Hence, I total is equal to I1 plus I2. Yes, right. Okay, so the current is the same either side. As if there's been no junctions, the current's not split up, and so I2 will go through that and still be the same on the way out. However, once it meets a junction, it joins back up with I1 and produces I total. So I total is equal to I1 plus I2. So if you have this equation here, I is equal to V over R, and then you can then say that I total is going to be actually equal to the voltage over the total current, and then we can do the same sort of thing with I1 and I2. You'll end up with a voltage at the top like this, and then they would just cancel out, and you'd have 1. So you'd have 1 over R total equals 1 over R1 plus 1 over R2. So that's a speedy little video there, but I'll just save that and publish it.